Welcome everyone. This is part one of System Operations, the Java side. On this particular session, we will go through the OutSystems Platform architecture and how to license and how to apply licensing to installations. And we will also go through the installation and configuration of standalone servers. Next session will be on farm installations and troubleshooting. So going forward with OutSystems Platform architecture, we'll have a short overview of the architecture, main services involved, what is required at runtime and at deployment, and the database and its data model, and how to address network and connectivity concerns. Finally, we'll show some of the server profiles that are relevant for the architecture, and we'll go from there. So architecture overview. So the platform, the core of the platform is a platform server. This is where this is responsible for the deployment and runtime context of the OutSystems applications. And this is where your applications are actually compiled and deployed to the final application servers. So your applications are developed in Service Studio, which is an IDE to develop web and mobile web applications using the platform. If your applications require functionality that the platform does not provide directly, we also have another IDE to extend the platform with by integrating it with external systems, or simply by integrating with external functionality developed in either C# or Java. Next is the Service Center, which is the platform server management console. Here you'll be able to manage the applications installed on the platform, and also monitor their behavior and the behavior of the entire platform actually. Finally, you have Lifetime, which is an OutSystems application lifecycle management tool. It allows you to manage and deploy the OutSystems applications across several environments. So it allows you to have multiple staging environments and push applications from one of them to the other. So Service Studio is a codeless visual environment. It allows application developers to deliver and modify web applications and services in a very timely fashion. Here you can see three of the flavors of things that you can do with Service Studio. So on the left side you have a screen being designed. So this is a what you see is what you get interface. The middle one shows the data model of an application, and you can see the connections between entities. And the right side shows how to develop, how to implement logic in the platform. So this is all very visual. Integration Studio, on the other hand, enables the extension of the OutSystems platform by creating custom adapters to integrate with existing databases, for instance, or external systems or logic that might have been developed somewhere else. So of these three wizards, one of them is outdated now. So SAP Wizard is no longer part of Integration Studio, since it became an integral part of the platform, and you will have access to it through Service Studio instead. The other two, you have a .NET Assembly Wizard, so to allow you to import actions from a .NET Assembly. And you have another wizard for database integration, where you can actually import entities from an external database and make them available to the platform. These are just a few examples of the wizards. You have more functionality directly in Integration Studio. So the platform server is the core of the platform. It contains two subcomponents: the deployment controller server, typically just called the controller, and the front-end server. So the deployment controller is in charge of compiling modules and extensions. So modules are developed in Service Studio, extensions developed in Integration Studio, as well as deploying the compilation result to the front ends. There is only one deployment controller server for each platform server installation. As for front ends, they are the environments where applications actually run. So they run a standard web application server. In the Java case, it's either JBoss, WildFly, or WebLogic, complemented with some extra OutSystems services that provide the rest of the functionality of the platform. So a platform server installation can have several front-end servers, whereas only one controller. Also, Service Center here depicted on the picture on the left is the centralized management console of the platform server. As I said, it allows you to manage applications and monitoring them. And Lifetime is the unified console that gives you visibility and management capability over your entire factory and OutSystems infrastructure. So between multiple environments, staging environments. So this is the main diagram for a platform server. The OutSystems platform comprises the development tools, which we've talked about, Service Studio and Integration Studio, and its server-side component, the OutSystems Platform Server, which we are now seeing on this diagram. The OutSystems Platform Server is the engine of the OutSystems platform, where applications are executing, data is stored, and it also comprises all the mechanisms responsible for deployment of applications and self-healing, self-monitoring services as well. There are three major logical components to the platform server architecture. The deployment controller server on the bottom right corner. This component is responsible for coordinating the whole deployment process. This is the component that performs the compilation of the applications, coordinates deployments to all of the front ends, and is responsible for managing the data model of the applications built with the platform, as well as the data model of the platform itself, the metadata database. Sorry. There is only one deployment controller, as I have told you before, in each installation of the OutSystems platform server. The front-end server, so the top part of this diagram here, the platform server diagram, is the component that is user visible. It's the user visible part of the architecture. So front ends are responsible for executing all the logic in applications created with the platform. So web requests, timer execution, business processes, web service calls, etc. So Service Center is also executed in the front ends, and there can be multiple front ends in each installation of the platform server. Finally, the database server is the component that hosts the database subsystems that contains the data model of the applications, which was designed by developers in Service Studio and is managed by the deployment controller. It also contains the platform's own data model that is used for the runtime of the various OutSystems platform services. So each installation of the OutSystems platform server will include only one platform database, even though integrations with other databases are possible, as I mentioned before. The actual physical architecture may vary, since it is possible to have these components in a single server or spread across multiple servers. The OutSystems platform server includes the following services, and of these, the first four are common to the Java or .NET part. The last one is specific to Java. So the deployment controller service, the deployment service, log service, schedule service, and RMI registry service. So this RMI registry service only exists in the Java stack and corresponds to Java remoting. So it's used to allow platform services to communicate between themselves. Okay, so it is required in all servers that have OutSystems services running. The controller, the deployment controller service, deployment service, log, and scheduler. There is no SMS support in the Java version, so that service does not exist in this stack, although it exists in the .NET version. So at runtime, we don't require the deployment controller server at all. It's used only for deployment of applications, and we also don't require the deployment service on the front ends because we don't require deployment again. So basically, runtime only occurs in front ends. Okay, front ends execute all the business logic, serve all the web pages and web service requests by end users, and modules published in the OutSystems platform are executed as web applications on the web application server. In the Java stack, JBoss /WildFly or WebLogic. These are accessed by web browsers from computers, tablets, smartphones, whatever device that can access a web server, and by other application servers and middleware through web services. So in an OutSystems Platform server, there is at least one front end. There can be many, depending on the needs of the actual application. And the following services are part of the runtime context of OutSystems Platform. So the application server is mandatory. It's responsible for executing all the application logic. Each module is deployed in the application server as a self-contained web application. So in the Java stack, it consists of a set of Java server pages, controls, and classes, which are hosted on JBoss WebLogic. Each eSpace or each module is deployed as a separate virtual directory, ensuring separation between each deployed application. The scheduler service is responsible for executing all the synchronous application logic. And this means timers, business processes, sending emails, etc. So the scheduler service itself does not execute any logic. Okay? It is only responsible for triggering its execution in the application server and ensure that the execution is performed correctly. Finally, the log service is responsible for all the execution and maintenance of the OutSystems Platform logging mechanism, from writing all the logs to the database to keeping the logs metadata healthy, as well as executing any maintenance tasks that are required. Service Center, the administration console, as well as Lifetime, the factory lifecycle staging and management tool, are also executed in the front ends, as it's in fact just another OutSystems Platform application, which was developed in Service Studio. Although all environments will have Service Center installed, only one will be running Lifetime. So if you have multiple environments in your infrastructure, only one of them will be able to be running Lifetime. So how do we deploy applications in the platform? Deployment is done using one-click publish. Okay? In Service Studio, you have a big green button in the middle of the interface. It's actually hidden behind the Service Center picture there, image there. And when you do it, when you click on that button, several things will happen in order. So first of all, Service Studio will upload the module file, the OML file, to Service Center, and this will be stored in the database. Next, compiling. So after you upload the server, the file to the server, it will initiate the compilation process. This process will generate the runtime web application files. This occurs server-side, and Service Studio is only being used as a way of displaying, of showing progress messages. Finally, deploying. So after a successful compilation, the application files are deployed onto the any available front ends. Okay? In development mode, there is the option to do a light one-click publish. You do that by using the run option. This will be F6 on your keyboards. This will create an individual sandbox, so a personal test area, allowing access to an updated version of the eSpace without interfering with the currently deployed version. Personal test areas can also be used for debugging application logic, making sure that it's not affecting the rest of the users or developers that are working with the application. But we need to be careful because not all changes to a module will allow you to use the run option to allow the partial deployment in a personal test area. For instance, changes to the data model will require a full one-click publish. So you won't, if you change something in your entities, you won't be able to run it just in the personal test area. You'll have to do one-click publish, which means everyone will be aware of your changes to the data model. So here we can see the several steps of deployment. So deployment in the OutSystems platform is coordinated by the deployment controller server, and it involves the front ends. The deployment controller is the component responsible for coordinating application deployment, as well as executing most of the tasks. So compilation of modules and extensions, updating the data model, updating the OutSystems metadata itself, and coordinating the actual deployment to the front ends. Each front end is responsible for executing and guaranteeing the correct execution of the application's files deployment in itself. So deployment service is part of the front ends. It's responsible for actually deploying in that specific front end. The following services are part of the deployment context. So when we're talking about how do we deploy an application in the platform, 4 services are involved. So the deployment controller service is responsible for coordinating the entire process. It's running in the controller, and the service is responsible for compiling the modules, so transforming them from the visual module created with Service Studio into a web application that can be deployed in an application server. And at the same time, making sure that the corresponding data model is updated in the platform database. This service is also responsible for the coordination of the deployment of these applications across all front ends in the platform server installation. Then we have the deployment service. And deployment service is responsible for guaranteeing the correct deployment status of each module in the front end where it is executed. So this runs in the front end. It's one deployment service per front end, so each front end has its own independent deployment service, and is responsible for obtaining the prepackaged web application from the controller and executing all the logic needed to deploy it in the application server. This means placing all files in the proper places, doing any necessary configurations in the application server, cleaning up any unnecessary files that are left behind after the process is finished, etc. Then we have the logs, which is actually not shown on this display, on this diagram, but the deployment process generates logging information. In the same way as applications generate that in runtime, the log service is also used here to make sure that the logs regarding the deployment itself are written to the database. And finally, we have the OutSystems compiler, and this is responsible for the first stage compilation process, basically the part where we transform our module's OML file into Java code and SQL scripts. So deployment of a module can be summarized in 4 or 5 sequential steps. First step, upon request from Service Studio, and this happens through Service Center actually, or directly through Service Center, and eventually Lifetime as well. The deployment controller service begins the compilation of the space. So this is so number 1 is Service Studio requesting uploading a file to Service Center and requesting that to be deployed or to be published. Number 2 is actually the actual request done by Service Center. So it stores the new version, the version of the OML file in the database, and at the same time it asks the deployment controller service to perform the compilation of the module. Okay, these are two stages. The first stage consists of converting the module from its OutSystems model into a Java web application. And the second stage is the actual compilation of the generated Java source code into using the native compiler, which will end up with a compiled Java web application. The product of that compilation process is a packaged web application consisting of web pages or UI, controls, underlying logic or code behind it, and this application will now be distributed by the deployment controller service to front ends. So that's number 4 there on the diagram. And the front ends will do all the necessary preparations to deploy them in the application server themselves. After that, you have step 5 there, which I will describe in 2 parts. But the first part is the deployment controller service then applies the changes needed to the data model of the application being deployed by executing the SQL scripts that were generated in the compilation step. These scripts will create or update any objects that require changing. So creation of new tables, adding columns to existing tables, changing column data types, that sort of thing. And as soon as that is completed, the deployment services in the front ends will finish publishing the web application into the application server by creating or updating the virtual directory that will host the newly deployed application. The deployment service will also verify the deployment was correctly executed, and it does this by accessing a specific entry point in the module. Successful deployment action implies that deployment was correctly completed in all front ends. If the deployment fails in some of the front ends, the deployment service will continue to try to deploy until it can do so successfully. Okay, and every time it tries to, it will log that for auditing purposes. So focusing now on the database server, the database is a fundamental component of the platform. This component hosts the database subsystems that contains the data model for applications. These were designed by developers in Service Studio and is managed by the deployment controller. It also contains the platform's own data model used for the runtime of all of the systems. This database can use either Oracle or MySQL in the Java stack. Architecturally, everything works the same way regardless of which one is used. And we have four main logical repositories. So the runtime database stores the data of all OutSystems applications running in the platform, except for those applications that are deployed to use an external database catalog or schema. The log database contains all the logs generated by the applications and any service that constitutes the platform itself. So both logs of end user applications as well as platform logs will be in the same log database. And then we have the metadata database, which stores all the OutSystems data, metadata, including information about each application, its data model, versioning, and data needed by the platform services for its runtime. This data is also used during the deployment of the application to automate change management of the modules and their versions. Finally, we have the session database, which is used to keep the data of user sessions in the web applications created with the platform. So this data includes login information, so the user that is using the application, if it has logged in, and also any data that the developer has chosen to keep in the user session. Examples of these are recent activity, search filters, this sort of thing that is reused across many sections of an application. Having the session module in the database allows the user session to be independent of which front end is currently executing its requests, which means multiple front ends can serve requests for the same user. The data in the session database is volatile. So if lost, the only consequence is that any currently logged in user would lose their session. It would be the same behavior as if the browser had restarted. But all other data is persistent and should be safeguarded. If it's lost, that means that you will possibly need to recover it from an early database backup. The physical placement of each of the repositories depends on whether Oracle or MySQL is being used as database server. So in Oracle, two schemas are used. One schema contains the runtime, log, and metadata repositories, and a second catalog contains the session model. Tables belonging to each of the repositories, you can easily identify them because they have specific naming conventions. So tables belonging to the runtime repository are prefixed with OS USR underscore. Tables belonging to the log repository are prefixed with OS log underscore, and tables belonging to the metadata repository are prefixed with OS sys underscore or OSLT underscore. Moving on to network and connectivity, we'll talk a bit about what's the physical architecture of an installation. So the OutSystems platform is designed to support complex network architectures and physical server configurations. The idea here is to give greater flexibility when structuring a setup for an OutSystems platform environment, that for a corporation or for a network for a corporate network with tight security requirements, and that may want to provide distinct applications for distinct end users. So to ensure reliable and fast communication between the platform services and components, the deployment controller, the front ends, and the database server must be connected to a high-speed network. This network can be segmented, and typically there will be a network for the OutSystems platform servers and possibly a database servers network. So one for deployment controller and front ends and one for the database servers. But they will be able to communicate between themselves because, well, our front ends and the deployment controller need access to the database servers. Front ends can also be separated in distinct networks. In the case of having a DMZ and internal applications, okay, so this is the example on the diagram there. In this case, the green front end, the deployment controller, and the database servers are in a high-speed internal network. This network is separated from the DMZ, where the orange front ends are located. These are, in turn, separated from the users by a load balancer and another firewall that separates corporate network from the internet. We will look into the requirements of a similar setup later in a following slide. So server profiles that are typical in this in the platform. The simplest situation is the standalone installation. It requires only one server or virtual machine. All components are installed in the same server. This setup can be used for small applications, but it will lack redundancy and possibly might have performance problems as it grows. So in a standalone environment, in the standalone setup, the following components are running in the server. The application server, JBoss / WildFly or WebLogic, the OutSystems platform services, so the deployment controller service, the deployment service, the log service, and the scheduler service, and the database, whereas it's Oracle or MySQL. In a farm environment, which actually is the most common setup of a platform server, distinct servers have distinct parts of the software installed, and you can have multiple servers being used for redundancy. So front-end servers will require the application server and the deployment service, log service, and scheduler service when it comes to OutSystems platform services. The deployment controller server will require also the application server, and this is basically because there are certain functionalities that are invoked through web services, and it's what provides the web services functionality, and the deployment controller service and log service. So the log service here is used to log all deployment activities. Finally, the database server, well, it requires Oracle, or it can be either an Oracle server or a MySQL server. It is also possible to combine the deployment controller server with a front end. This is actually the most commonly used scenario. So pure deployment controllers are rarely used, and we will be able to see that later in this series. So what are the main differences from Windows? So platform installation and operation is 100% command line driven, so there is no graphical user interface. Multiple stack combinations will increase complexity, so we now have multiple application servers and multiple databases, etc. And Java requires auxiliary RMI service to look up the OutSystems services. And finally, since there is no SMS support, means that we don't have the SMS connector service. So this is a fairly simple grid showing what services are required for each of the profiles. We have 3 profiles: deployment controller, front end, and platform database, and we have 5 services plus the database engine here, and we have this is basically a roundup of the previous slides. So here, to combine multiple profiles into one, we just need to make sure that the services that are needed for each one are running on that server. And there's a tech note on the on our website about platform architecture. So how do we configure a profile? So this is actually a change not available on the Windows on the .NET stack. So we can actually enable or disable services depending on the intended profile. We just need to use the service configurator shell script and provide it with the profile that we want the machine to have. So if you want a pure controller machine, we'll use -controller. For a front-end machine, we'll use -frontend, and if you want a combined roles machine, we will use -all, and it will have both the front end and the controller. This will change the machine-based service configuration by disabling and not just stopping the OutSystems services that are not needed for the profile that we are selecting. This means that it is maintained between machine reboots. So as soon as we execute this script, next time we reboot the machine, it will remember what's the profile that's being that's in place. Services specific to JBoss or WildFly. So in the deployment controller and the front end, we will need to have 2 extra services: JBoss OutSystems and JBoss OutSystems MQ. So remember, and again I will stress this, the application server needs to be installed and running even in a pure deployment controller that doesn't really have any end user interaction. This is needed because some internal services use APIs that are provided by supported by JBoss or WildFly. Still, no applications will be deployed to it. Okay, so in the JBoss installation, you'll have 2 instances of JBoss actually running. JBoss OutSystems is the instance that will be handling the application server functionality itself, so serving pages, running web services, etc., as well as the application management, so that's where you do war deployment, etc. And the JBoss OutSystems MQ is an instance that is just used for message queuing functionality. And the reason for this dual instance, dual service approach is so that if there are any failures in the application service functionality that might require a service restart, it doesn't take down with it any log messages still waiting to be flushed to the database. Okay. Unlike WebLogic, that is a dedicated service. Unlike WebLogic that has a dedicated service, in JBoss WildFly, the main instance also hosts the application management API. So WebLogic, which we're not going to go through here, has a specific independent service for a third service for application management. And this concludes our introductory architecture feature. And we're now going for licensing and how licensing works with the platform. And here we have several bullets to go through. So first of all, licensing overview, main concepts of licensing in OutSystems, and how to license an environment and what kind of features are licensed. And finally, since we are talking about licensing, we will also mention intellectual property protection and how to make sure that your work isn't used in a different organization without your permission. We will end with invalid licenses. So what causes an invalid license and what are the consequences of having an invalid license on your platform. And we'll go through the overview first. So all licensing operations are executed in Service Center. So these aren't developer activities, so Service Center is the place to manage these. Each individual installation has a separate license. Distinct installations, so development, quality assurance, production, will use different licenses, but think of front ends, multiple front ends as a cluster. They will share a single license. And when you purchase the license, the customer gets licenses for multiple installations. The actual number will depend on what kind of a contract you have. You might have 3, 4, whatever that number. And the main concepts here regarding licenses is, first of all, an individual installation of the platform server is called an environment. A set of environments is called an infrastructure, and I've used these words before, so to introduce them more subtly. Activation code uniquely identifies the infrastructure, whereas each environment will have a serial number. And finally, there's a binary license file which is generated for a specific serial number and will be bound to an activation code. And this file is what you will actually install on your service center. So licensing an environment, you will need to access the licensing console. So this is a self-service task. Once in possession of an activation code, you will be able to access this console through outsystems.com/licensing. You'll just fill in your activation code, make sure that your CAPTCHA is correct, and proceed. This activation code is sent by email upon the initial purchase of the OutSystems platform. If you already have one licensed environment, you can also check what's the activation code from the licensing page in Service Center. So the licensing page shows an overview of the license characteristics and a list of entitlements. You will be entitled to a given number of environments divided in two types. So production environments, these are entitlements to be used for your production environments, and development entitlements, which are to be used for all non-production environments, so development, quality, that sort of environments. License files are different if generated under production or development entitlements, so be careful to register your environments correctly under the proper type. If you make a mistake, you'll need to contact OutSystems to undo it. So entitlements which are in use will display the Get License button that you see there. Clicking on that button will trigger sending the license file by email to the authorized contact list. So OutSystems will add or remove contacts associated to an activation code upon request. So if you are you require to receive those licenses, then you need to request your email to be added to that to your account. Entitlements which are not in use will display a Register New Environment button instead of the Get License. This allows registering a new environment by introducing its serial number. So when you install the platform, you will get a serial number, and if you come here and set that serial number as a new environment, after this operation, the entitlement becomes in use, and you'll be able to get a license to install on your service, on your platform server, and become valid. The Get License button can be used infinite times to obtain the license file, because the license file will always be the same and there won't be any additional licensing costs. This means that you can actually use the licensing console as the safe place to store your license files. If you ever need them again, you just need to come here and click on the Get License and obtain them again. A license file can be uploaded countless times. So Service Center only keeps one license, and that's the last one that was uploaded. It is possible to obtain a copy of the currently loaded license by clicking on the backup license there, the second link there. It is recommended that you always back up your current license before installing a new one. And if you click on the Request a New License, you'll end up being brought to the licensing console that we've just seen. So when uploading a license file, if the license becomes invalid, it is necessary to verify if any of the features became invalid with the new license. If the serial number matches the serial number of the license file, or any other error message that might appear. So it might happen that you upload a new license that has less privileges or different values for some of the functionality that is licensed. So you might need to check those limits. In Service Center, you can access the licensing page. It's in the administration. It's the last item on the menu, so licensing. And this is where you will be able to obtain all the information and perform all operations regarding licensing for this installation. So you have licensing status section, where whether the license is valid and within limits, valid but almost exceeding limits, or invalid because it's exceeded limits, or wrong serial number, or simply not found. So it will show up, see the green part there, the green message there, so it will show information regarding your license, whether it's valid or invalid, and why. Licensing details, so organization name, edition name, etc. According to the entitlement that was used to generate it, it will show whether it's a development or production license type, and the expiration date, serial number, and activation code. Finally, you will have a detailed list of features, including limits and the current usage. So in this case, you see there unlimited, so usage is irrelevant. But if there is a limit, usage will show you how much of that feature you're using and how much is still left available for usage. Okay. So audit license there, which we haven't focused yet, generates a text file with the licensing information that you can see in this page. It's nice for troubleshooting purposes. And registered end users, end user sessions, and software units. It allows you to check the usage details for these features. So instead of scrolling down to the particular feature, you can see the end users, registered users, or software units. So recent licenses have application objects instead of software units there. And the kind of things that are license users, and these can be end users, so application users, or development users. There are two different settings for these, so two different licensable features. Software units or application objects, integrations, logging, monitoring, and analytics might be different depending on the license. For instance, if you go to your personal environments, analytics is not licensed. Security and authentication, namely LDAP and integrated authentication, and scalability and availability features like multiple front ends or data segmentation using different database catalogs or schemas for different applications. Another one that's not mentioned here but is also it depends on the license is lifetime, and you can check those actual details for the editions on sale if you go to the OutSystems website. Intellectual property protection makes sure that your components that you develop on your environments will be branded as yours. So every time you create a component on your factory, there will be information added to the module with the infrastructure activation code. Okay, making sure that you can't deploy them directly in other infrastructures, so you avoid espionage and that sort of thing. It is possible to move components between infrastructures if you use outsystems.com/IPP interface, unless the infrastructure owner, so the infrastructure where the components were created, opts into IPP protection by contacting OutSystems support. Okay. So if you attempt to do one-click publish of a component in an environment of another infrastructure, it will have an error. If you try to one-click publish in an environment in the same infrastructure, even if it's a different, so if same infrastructure, different environment, it will work as expected. And this boils down to all the environments of an infrastructure must have the same activation code. Okay. Since activation of IPP is optional, you need to opt in by contacting OutSystems support directly. So support@outsystems.com, and if you do that, then you won't be able to use /outsystems.com/IPP to move components between infrastructures. So what is the impact of an invalid license? So first of all, one-click publish is disabled. So you can't deploy new applications. You can't do any sort of bug fixing to existing applications because they require one-click publish. And you can't roll back to earlier versions because, again, this is publishing a previous version. So one-click publish is disabled. Certain features of Service Center become unavailable as well. So you can no longer create users or roles, since users is one of the things that's licensed. Advanced logs and report generation will become unavailable. So this is analytics as well. And configuration of license features is unavailable because you don't have any license features. Your license is now invalid. Applications enter limited functionality mode. Means that some of the scalability features become unavailable and you can't create new end users. Okay. And the impact of an invalid license is if you have a subscription license, the applications will continue to run for a limited time, but then they will become offline and you'll see this screen. Okay. And this limited time is basically 12 hours at most, because applications will check the licensing information every 12 hours. So at most, within 12 hours after license expires, your applications will shut down and become unavailable. To prevent unexpected downtimes, we send emails. Okay, so OutSystems licensing department sends email alerts 3 months before, 2 months before, a month before, 15 days, 7, and 1 day before the license expires. So you have plenty of warning so that you can renew your license or decide what you want to do. Finally, in Service Center, you will see alarms, so red on your screens, informing you that the license is invalid and will shut down. Okay, so if you go to the licensing page, you'll see this rectangle there with your license has expired, contact us. And on the right corner, right topmost corner, you'll see this gray rectangle which always displays information about the license. So you can see here if the license has an error, and in this case it's expired, or if it's almost through with available resources, and you'll be able to see it in all screens. You'll see this info card there. If you want to ask for support with OutSystems, you have the support portal. This allows community users to submit new issues, receiving immediate feedback on forum posts, knowledge base items, or other existing issues that may relate to the case being submitted. Furthermore, it allows users to check all the issues submitted from or to infrastructures to which they are added members. So if you are part of a certain infrastructure, you'll be able to see all cases for that infrastructure. On each issue, it is possible to see all the communications between who submitted it and the OutSystems support, so you'll be informed of what's going on. And this wraps up our licensing section of this talk. And now finally, final part, installation and configuration. And again, we'll deal with standalone installation. So from these points, the last 3 will be for the next session. So first of all, we'll have versioning, so describing what's the versioning mechanism, how the platform is versioned, what the numbers mean, etc. talk a bit about the installation checklist that we provide to help you, to guide you on the installation, and what's there to do in a standalone installation, and how to use the configuration tool that we provide to help you. Okay, so OutSystems Platform versions are numbered with 4 numbers: major, minor, release, and revision. Major version number and minor version number together represent the version of the OutSystems platform. So together they are also intended to match a marketing version of the product, like 9.1 was Bali, even if they have a different name. Okay, so new features, enhancements to previous ones, additional capabilities might have breaking changes. A new release, so the R, is issued whenever a complete package is distributed with significant improvements to current functionalities, but without breaking the existing features. So an update to a new release keeps the compatibility with the previous release, as long as the major and minor don't change. So it does not introduce breaking changes with previous release and does not force an update to components of the OutSystems platform. Finally, the revision, new revision patch indicates an update to the platform that introduces bug fixes or minor improvements to features. So a new revision does not introduce breaking changes with previous revisions and does not force an update of all components of the OutSystems platform. And as soon as you upgrade to a new revision patch, you no longer can come back to the previous version. Okay? If you want to know the versions of the OutSystems platform that's being used, you can do it in Service Center. So the version is present below the licensing information of the top right gray box that I mentioned earlier. In both Service Studio and Integration Studio, this information is available under Help About. And in Lifetime, the version is available at the bottom of every page. So what's versioned in the platform itself? So the development tools, and this is Service Studio and Integration Studio. The platform server at 3 different levels. So the installer itself, the version of the metadata in the database, and system components, Service Center, and Lifetime. And finally, components, as in modules, extensions, and solutions developed by developers. Okay. This versioning implies that development tools can only connect to a platform server that is running the same major minor version. So the first 2 numbers are the same as the ones on Service Studio or Integration Studio. All version components within the platform server must be running on the same revision. So all 4 numbers must be equal. And all components that are published in the platform server must have the same major and minor as the platform server where they run. So when publishing the components, they will be compiled to the current platform revision. So if the components don't show information that have been compiled to the current revision, it means that they haven't been published since the last revision update. Okay, which means that there might be inconsistent states, so you should publish them again so they are compiled to the latest revision. The development tools can open components which are in a major minor version that is equal or lower to the one of the development tools themselves. Okay, for instance, Service Studio 9.1 will be able to open 9.0 and will also be able to open 8.0. Okay, opening a component of an earlier major minor version will be upgraded. Okay, this is not reversible. So as soon as you upgrade and publish, you cannot downgrade to the previous version. Okay, and a platform server that is running a given revision cannot be downgraded to any earlier revision. So from the moment the metadata is upgraded, the only way to go back is to restore from a database backup that you might have. Okay. So moving on to the installation checklists. The installation checklist is a dynamic document, dynamic HTML document that presents the sequence of steps that you need to perform in order to install the OutSystems platform. These include the software pre-requirements, installing the platform and configuring the platform, and eventually tuning recommendations. Okay. There are several things that can be and that should be configured on the checklist. So what's the task kind? In this case, you'll see there it's first install. It can be either a first install, an upgrade, or a revision patch. So you need to understand versioning in order to understand which of the tasks you want to execute. What is the server profile? And by default, it will show deployment controller server and front-end server. But it can be a pure controller, a pure front-end, pure database, platform database, or a combination, any combination of these. So it can be just the front-end and deployment controller. It can also be deployment controller, front-end plus database. Okay. Whether the installation is a standalone or a farm. Here it's a standalone, means that everything will be installed on the same machine, same server or virtual machine. Okay, and depending on this option, some of the server profiles might not be available, because if we say it's a standalone, there is no point in just having a pure controller, for instance. Okay. Also, we have the operating system and the application server. And finally, we have the database engine that's going to be used. In this case, it's MySQL. It could have been Oracle as well. You can obtain this checklist two ways. So it comes with the installer, okay? And after a successful installation, the checklist will be available in the docs folder inside of the folder where the platform was installed. So typically, this would be opt/outsystems/platform/docs, or is as a standalone download that you can find at the OutSystems website. And be careful that checklists varies according to the version being installed, so make sure that you select the correct version for the checklist. Otherwise, your instructions might be slightly different from what you actually get. So in a standalone installation, you have pre-requirements that you need to make sure things are installed and make sure that they are properly configured before you even start installing the platform. Then you have the installation of the platform database and the platform itself. And this means both the setup of the platform services and database, as well as installing Service Center. And finally, you have the licensing of the environment after you've registered it in the licensing console. And finally, deploy the system components so you have a properly complete installation and ready to be used. Okay. So in a standalone environment, you will need to install all roles. So the database, deployment controller, and the front end. Okay. And there's an option in the install checklist that includes all three roles. So use that one so you won't miss any configuration steps. Namely, the database configuration steps you might skip. Based on the checklist, you need to plan your installation. Okay. So prepare a comprehensive schedule of the installation with timeline for pre-installation and post-installation tasks, including preparation of the hardware, of the software, installing the platform itself and configuring it, and making sure that you test the installed platform to make sure it's working. And finally, once you have the planning, you actually deploy the server, you execute the planned tasks. So we'll now go through the configuration tool, which is the back end of the OutSystems Platform Server configurations. And most settings typically are configured in Service Center. But since Service Center is a web application, some things need to be configured actually before you have an application running. Okay, things like the database connections, the server locations, the service configurations, and other low-level configurations. These need to be executed before you actually have any web application running. The idea of the configuration tool is that you just set it up once and forget about it. Okay, you will need to go back to it every time you add a new front end, for instance, or you want to make some deeper changes in network scenarios, for instance. So configuration tool is installed with each installation of the OutSystems Platform server. You can access it through configuration tool shell script. And you have three main sections on the configuration tool: database configurations, farm configurations, and advanced configurations. These are the main ones. Going in detail, in the database configurations, you will be able to configure the main database connection, and this includes the server, the schema, and the users that will be used to access it, and also create or update the OutSystems data model itself, so the platform data meta model itself. Also configure the session database, and this is all part of database configurations there. Configure the log service and the scheduler service, and also the deployment controller and deployment services. And finally, network-based settings. These are useful, particularly useful in the farm scenarios. So this is an example, and we're going through the MySQL example. The Oracle one is fairly similar. The only difference is in the advanced configurations for the database. So we'll not go through there. So first of all, we need to select which is the database server type that we need. And this is either Oracle or MySQL in the Java stack. We also need to provide it with the configuration with the location of the database and with the users. Okay, so we need to give it the server, the schema, and three users: administration user, runtime user, and log user. So the administration user will be used by the platform in all operations that change the database model. It is in the schema of this user where all objects will be created. Default name is typically OSAdmin, as you can see there. The runtime user is the user that all applications will use in runtime to access data. Okay, so the OSAdmin will be the one modifying the database model. The runtime user, OS runtime, will be the user adding data or modifying data in the platform. So it will have the strictly needed privileges to read and write data in the model. Okay, by default it's called OS runtime. And finally we have the log user. This user is used for all log writing tasks in the platform, as well for the logging mechanism maintenance tasks. Default name is OS log. And these users are meant to be created specifically for the OutSystems platform. So ideally they are different users than the ones that already exist in the database. In Oracle and MySQL, actually, the checklist includes instructions to customize the script that creates the users with the needed privileges. So it's not automatic. You need to run a script afterwards to create the users, eventually create the data model, etc. So the names, so these are default names. These names are a suggestion, okay? Still, the actual names given to the users should respect their role. You should have some association with admin, runtime, or log, because that will help us understand what's their purpose and what should be their privileges. Once you configure once you complete the configuration process, the configuration tool will prepare the OutSystems metadata for the version of the software currently being installed. So configuration tool is based on a specific version of the platform, so it will install that version of the metadata, and it triggers the execution of a series of SQL statements that update the data model to the appropriate version. And here there are three possible behaviors. If the data model doesn't exist, or if it's blank, or if it's an older version of the software, of the platform, then it is updated to match the version and revision of the software. Simple as that. If the data model is up to date, nothing is done, so it silently continues. And if the data model is newer than the version of the software, so we are trying to install a previous version of the platform, then an error message will be displayed. So we cannot install previous versions of the platform, and you can see that by the database itself because it's also versioned, remember. In case of MySQL, we have advanced settings, and these are runtime JDBC URL parameters to provide extra connection string settings. Okay, you have them both for the runtime, so for end users, for the user that's the connection that's used by applications, as well as for the services. So you have two different settings. And then we go through to the session database. And here it's fairly similar. We again need to tell what's the server, what's the schema that's going to be used for the session database, and what's the user that's going to be used for writing the logs, for accessing the logs. Okay. So the session database requires a separate catalog or schema. In this case, it's a schema with Oracle, which don't even need to be running in the same database server or instance. Okay, and we have specific user credentials for this. So the session database needs to be on the same database type, so it needs to be either MySQL or Oracle. It needs to be the same as the main database, as the metadata database. Okay, so we don't have that choice here. So the only choice that we have is what's the server and what's the schema that's going to be used. And the session user, by default, its name is OS state, is used by the platform for everything regarding session model. This user will be the owner of the session database catalog, I was thinking about SQL Server. Sorry, in an Oracle setup, it's the schema of this user that will have all session objects. So all session objects will be created in the schema for this user. Okay. The configure session database. So once this is finished, this will generate another script. You have instructions on the installation checklist. So the sequence here will create only the necessary objects for the session model, and these operations will be executed with the session user itself. So in order to create the user, you'll need to execute the script that was generated. Okay. The advanced settings shows extra advanced parameters for the connection strings for the session database, which is similar to what you had on the database. So extra parameters for the connection string. In farm configuration, so we are now going through the second step, farm configuration. You will be asked for the controller address, and localhost will probably be the default. And for a standalone environment, you can leave it at localhost. But in a farm environment, be careful. This needs to be the IP host name or fully qualified name of the server. Okay, so this cannot be localhost. It needs to be the IP. In a farm environment, it needs to be something that identifies uniquely the controller. Front-end registration, local IP address, is the IP address that this front end will use to register in the deployment controller. Okay, and this is the only setting that can change between front ends. So everything else needs to be the same in all front ends, including database configuration, the controller hostname, etc. This is the single thing that can change between front ends up until now. And this setting is useful if the machine has more than one network adapter, because it will allow you to select which is the network that the OutSystems services communicate with each other. Okay, Automatic will choose either, or if you have more than one, you will be able to explicitly select the one that you want. In the advanced configurations, you have several things here. So the first thing is the default query timeout for the database connection settings. This setting is used to control the default amount of time a query in the application is allowed to run. Okay, this setting can be overridden in individual queries in the application logic, so you can go there and specifically set the different timeout. But the default is that all queries abide to this one. Okay, and by default this is 30, but you can change it. 30 seconds, sorry. The unit is not there, but it's always seconds. The second one is the database update query timeout, and this controls the timeout of each individual statement run during data model updates when you one-click publish. Okay, so a good rule of thumb here is to keep this value about 20 times the value of the default query timeout. So in this case, that is 600 seconds. So the three next ones, the application server configurations. So an activity timeout, minimum size and maximum size. So these are used to control the time a connection is left in the pool without activity, the number of connections available, the minimum number of connections available in the pool of connections, and the maximum number of connections. Okay. Then we have the scheduler service, and here we can configure the maximum number of concurrent timers. So simultaneous timers that each front end executes. Okay. This setting is global, but it applies per front end. Okay. So in an environment with two front ends, for instance, setting this value to 3 means that at most you can have 6 timers. So 3 concurrent timers per front end. We have 2 front ends, so 3 times 2, 6. Okay. For logs, we have the log cycle period, and here we actually have the unit, so it's weeks. By default, it's 4 weeks. This setting specifies the size of the log history that is kept on the database. So possible values go from 1 to 10. So 1 means you only keep the current week, and 10 you keep the current week plus the previous 9 weeks. The default is 4, which means we store the current week and the 3 weeks behind that one. But you can change it between 1 and 10 again. Finally, we have internal network. And internal network, it's to allow us to select internal resources that can't be accessed by everyone, that are restricted in somehow. So applications in OutSystems Platform can be defined to have some of or all of its resources, so we're talking about web screens, web services, etc., marked as internal network only. Okay? This is an easy way to restrict access to internal applications, and the first one that comes to mind is Service Center. So Service Center is entirely internal network only. Okay, and this setting here allows you to configure the IP ranges that are that can have access to those applications. Okay, so if the setting is blank, any source is valid. Otherwise, only the IP or IP ranges configured are allowed. Okay, note that when configuring internal network, if you don't leave it blank, then you need to forcibly have at least 127.0.0.1 there. Okay, so regardless of any other IPs, the local host, but the IP 127.0.0.1 is mandatory. Failure to do this will lead to the platform misbehaving. Okay, also, if we are in a farm environment, it is recommended that the IPs for all front ends are included here as well. Okay, so if we need to communicate between front ends, then this is where we need to have that configured. So IPs for all front ends should be included here as well. Finally, we have RMI port, which is used by the platform services. By default, RMI service uses port 2033. Okay, so unless there is a good reason to change this, you should leave it as is, but you can change it to whatever you want. Okay. Okay, so what happens when configuration tool, when you did all the configurations you had to do on configuration tool and finally finish the flow, the workflow and exit? So the first thing it does, it saves all the settings to a local file. Some of these settings will also be propagated to the database because, well, there are applications and other services that will read them. And in a farm environment, that means that the last one to run the configuration tool is the one that will actually have the settings stored in the database, so be careful with that. And it also starts or restarts the log service, deployment controller service, and deployment service, and also the RMI service. It will ask you to start the scheduler if it's stopped, and it will prompt you to restart the application server if it's required, and to recreate the session model database if needed. Okay. So some other things that will occur. Behind the scenes, the configuration tool will test the connection to the database, making sure that the database settings you have work, both for the metadata database and the session database, and will configure application server with the platform settings. Okay. It will save the database connection strings, and these will be used in farm environments to make sure that only valid front ends will be able to connect. And well, that's it. The rest I've explained already. And this is what it looks like once you finish the running your configuring the configuration tool. It will update the platform configuration files. It will ask you if you want to update the session catalog, if you want to restart the application server, and if you want to install Service Center in this case. Okay, so SC install is Service Center, and then it will just stop the services and start them again. Make sure that everything is working using the most recent configurations. In a farm environment, some things are essential to keep in mind. So it's essential to keep the settings equal among the several front ends. Okay. Many of the settings are saved in the database, as I mentioned, by the last server where the apply and exit was pressed, or when the configuration tool finishes running. So if you have different settings between front ends, this means that services running in each front end might have different configurations, and this will yield unexpected results. Connection strings must be exactly the same in all front ends. So the database settings must be exactly the same, because for security reasons, we are checking those connection strings when front ends communicate with the controller. Okay, if they don't match, then the front end won't be able to register with the controller. Okay, so in a farm environment, best practice is to make the settings in one server, copy paste the configuration file, so server.hsconf, to the other servers, changing just the front end registration IP address if needed. Okay, and keeping everything else. So make sure that you have the correct configurations in the first server, and then just copy that, making sure that you don't have any of these issues that mentioned here. Okay, so this is a wrap up. So next session we'll follow up with the farm installation and the troubleshooting.